standard, and it's the simplest basics. This is the foundation of machine learning. I'm using supervised regression to teach you about all the most basic modules in each of the components that we covered in a nutshell. All right, so again, to review, ML grew out of the work in AI. And so this class uses this nutshell view to understand every machine learning algorithm. And these are almost orthogonal components of the machine learning, important components relevant to the machine learning. So it's data, task, representation, scoring function, search optimization module, and then the module properties and the parameter properties. So the rough sectioning of this class, so I did not cover very detailed, but just to put it here for every future class, I'm going to have this page just to let us know where we are. We're in section 1, which is about basic supervised regression and on tabular data. So today we're going to cover the linear, multivariate linear regression. And then this is the view of the linear regression in this nutshell. So let's go over each one of them, one component at a time. So we are going to, the first module in today's video will be tabular, about data and about the regression task. So again, about tabular data, so it's mostly those in the matrix form. And they're represented as a matrix, and then features are different columns. So these are different X1, X2, X3 features. And then we have different samples as different row. So this is the first sample, second sample, until the normally we call there are totally n samples. And we normally also use notation P to represent the number of features. So which means our input X, it's mostly in this matrix form, which is a n times P matrix form. And we write as a math capital X. That's how we normally write the X. And in the regression case, our output Y is a continuous valued variable. So just to make it simple, we first started from, there's only one single variable to be predicted in the regression. But it just totally, everything we learned here, can be easily adapted to when you have multiple regression outputs. So again, the two modes of supervised regression. So we have the training data. We can normally write them as X train, and the Y is given. So the Y prediction vector is given. It's Y train. And we just give to this predictor, it will give us a model output, which we normally denote as F. And then for the testing phase, we are normally we will give this F function a number of multiple test samples, which is we normally denoted as X test. And then we will apply F function on it. And then to compare the X test versus the Y test. So this is the metrics that compare FX test and Y test are the true generalization area that we care. So again, to emphasize, the machine learning, it's about generalization. It's about to generalize to the future data. So we use the testing portion to pretend as future data. All right, so now I'm going to actually do a walkthrough of a linear regression example from scikit-learn. So now I will share from another screen. So this is a linear regression example from scikit-learn. It's super easy. So again, I segment them into different parts. So if you cannot read the code very clearly, please do let me know. So I just decompose the code from this linear regression code, like a big chunk of code, into different parts. That's almost relevant, kind of mapping. There's a good one-to-one mapping to our nutshell view. So first, we just import the matplot library and NumPy. So I'm going to talk about NumPy actually in the end of this lecture, and about why do we use NumPy. And we, again, similar to the last L2 example we had, we use scikit-learn and we import data. But this time we import a different model, which is called a linear model. And again, we use metric. And also this time we use a slightly different metrics. It's the R2 score and mean square error. All right, so again, very similar to the supervised classification case. As always, we first load data. So we load data, and in this case, extremely simple because this is part of scikit-learn diabetic data. We just directly load it using this load function. And then we use one of them as feature. So because it's easy to visualize in this example. And then we just do very similar like we did in the supervised classification. We split the reference data that we know the Y into training part and testing part. We named them as xtrain and xtest. And we named the Y part as ytrain and ytest. So very totally the same as we had on the supervised classification before. And then, so this one, I just plot it. So there's a very easy plotting function, especially in the regression case. So if I can draw, let me try to draw. So the x-axis in this case, the scalar plot really just plotted into this two-dimensional grid you can think about. And then the x-axis is x-axis is just the horizontal line direction, and y-axis, the vertical line is the y-axis. You just use those x-y pair numbers, and then you place a dot, and that represent x-y relationships. So you can actually tell this training data is pretty messy. I mean, but we want to associate the just to get the f function. Hopefully, so let me write it now. So this is the x and this is the y. I want to learn a predictor that predict when you are given an x and you want to be able to predict the y as close as you can. So the simplest regression model is the linear model. So which means we just fit a line there, fit a linear line there. So let's go downward to see how do you do this. And very simple again. So you just select what regression model you're going to use. This is called linear model.linear regression. And you just fit, this is more like that computer. You provide training data, training input, and the training output, and you let this computer fit the linear regression model on my data. After you have this f function learned, So let's keep this in mind. And then this is called a fit function. After you have this learned, it's already you fitted well. So this is already learned. Part of it, this is already good fx, and you use it to predict on the future data. So that's the function predict. And then the prediction is applied upon the x test, the input of the x test. And this diabetes y predict is the predicted output. So this is the y equals to, so it's in fact, if we put subscript to just represent the r, so the y test is the one you apply the f function on the x test. All right, so very clear training phase and testing phase. And the next phase, I think we run this already. And then the next phase is to output what it's your model, right? So in this case, actually our model, it's this looks really odd number. There's also a mean square error. There's also this the coefficient of the determinant. We're going to talk about what do we mean this 0.47 in the last module of today's nutshell. So what are the good metrics? Why do they make sense to measure the predicted regression versus the true regression? So this is just the model, the coefficient, but let's see visually what do it do on my testing data. So again, I use the scatter plot to plotting my testing data. So this is the truth. So this each black point are the x test and the true y test. So x and y. So this is the truth. And because I'm getting a linear prediction, right? So my prediction are in fact or on a line, and then the predicted y predict are actually all those points on this blue line. So we can actually tell, yeah, so it's roughly fit the trend, although not exactly perfectly fit my testing data, but it actually truly fit the trend, not badly. And this is extremely simple regression model. All right, so now let's see one more, and let's put the training data and the testing data all at one plot. So this is more than that regression provided by scikit-learn, and this is what I added. So I think this whole thing almost a smaller version of your homework one. So we're going to in fact implement the predict function and implement the fit function from scratch. But the bigger workflow are exactly similar. This almost the same as this. So again, we, as a data person, we really like visualization. So let's see what is this learned line. So the training data are all the red points, and the testing data are the black points. So yeah, they're indeed. So if actually more correctly, it should be very, very long, and from infinity, positive infinity to negative infinity. This is an okay approximation of the relationship of x and y. So that's the regression model really tells me. All right, so let me now come back to my, so I'm going to stop share the code. So again, the two modes, right? Every time I'm showing you the two modes, I think hopefully you're not sick of it, because this is about homework. So I want you to be super, super familiar with this, and then making the homework will be a lot easier if you're very familiar with the concept. So the computer, what we use there is that reg.fit function. And then the prediction function actually we used is the reg.prediction function. So you can think about they're almost the computer they are in exactly this computer panel representing here. And this is what you need to implement in the homework one. All right, so now I need to, I want to show you, so what I showed you is a linear regression, and there's only one dimensional X input. So as I promised, I want to go over some COVID-19 cases. So I found this from Kaggle. You can actually click. So my slides is already in our course website. So it's updated. It's the most current version. I normally update the slides about like 20 minutes or 10 minutes before the class gets started. So you can just use that slide and if you want to do some annotation by yourself. So click the link, the Kaggle, and now I'm going to switch to this notebook views. Helpful. All right, so this is the, in fact, I think this is my version. Yes, this is my version of this because I just go to Kaggle. I encourage you to do the same thing. So yeah, this is my version. And this is the original version. And Kaggle has a lot of, there's an open competition called COVID open competition. There are many, many different tasks. I believe this is one of the tasks on week 4. I'm not completely sure, but I found this is a very nice Python notebooks, and then it's just show truly you actually can do a lot even though you are just a beginner. So this notebook did really great visualization, like visualize the proportion of the active cases, disease cases, or recover cases. And then it also has, but I think this is all standard, but it's great to, it's important to realize as a beginner, you can also do that too. Okay, so now let's come back to my version. I actually just copied it and then I edited, make it a little smaller because there are many, many functions in that notebook. I only had, so first, again, we import very similar to the smaller linear regression case. We import Panda and we import NumPy, but there are more import here. So what I want to show you is, so the regression is not just a linear regression. There are actually many other types, like XGB, like this gradient boosting based regression, and another gradient boosting based regression, and also random forest regression. These 3 are very powerful, state of the art, and then they have the metric too, like the mean square error, like mean absolute error. They don't use R2 here, but it's just one of the possible choices. And there's also a model because this is time series data, and very popular model called ARIMA model. So maybe some of you already learned it in the time series analysis, but we're not going to cover it actually in this class. All right, we ran it. Hopefully it's still correct. Yes, it's correct. And then it's a visualization. It's a really simple visualization pie chart. And you just visualize the proportion. And this is just visualization. So I'm not too much about regression, but I just still want to show you it's good visualization to show the proportion of your examples. And these are great visualization tools for you to use and to understand data. And then this is the data. And then I think this is a pretty expensive. Yeah, I think this one just show the confirmed curve and active and the death numbers from the current data. What I wanted to show you is the next. So you can already tell from this run through, it's a lot more complicated than our linear regression, but the workflow are actually quite similar, and you just have more fancy visualization parts there. And hopefully this still run. Yes, so this is the moving average curve. You may already read this for many other places, and it's really not that difficult to draw by yourself. And then I think this is a curve, also a moving average curve. Oh, okay, this is not. This is more like a scatter plot. It's very similar to our scatter plot, what I showed. So, but the x-axis is this death rate per million, and the y-axis, it's not a completely a numerical y, but it's a discrete set. So from here, you can see very clearly how the different states and and the color means different date. It's just all powerful tools, visualization tools. All right, finally we come to prediction. Again, train, test, split. And actually in this case, there's no train, test, split. You just load it for the current. And then this is a model called profit model, and I don't want to cover it. It's much more complicated than our linear regression model. But this is the much more nonlinear type of regression prediction. So I'm using my past to predict my future. So here you can see this part is the predicted, and then the ARIMA model. It's a very classic time series based, in this case, regression prediction. So keep in mind the regression type of prediction, it's in fact very useful. Maybe especially like in the time series analysis, in this case, like exactly analyzing COVID-19. So this is the current data, and then this is the prediction on the next 15 days. And then the author also had a lot of other predictions, and I think it's the prediction it's in here. So there's also this Bersin tree-based regression and a random forest-based regression, and also XGBoost. You can actually tell, I mean, the prediction is super easy. Again, you just tell the computer what regression you're going to use, and this is the name of the class, the regressor, and that you just use the fit function to train and predict function to deploy and to test. And I think that